All right, good morning. Happy day 2 of Summer Academy. It is Wednesday, July 7th of 2021. How's everyone doing today?
Good.
Good. Okay. No problem, Javon. So good morning to Yankel. Good morning to Branson, Jason Sanchez, Javon Tyson, and Daniel Flores. Thank you guys for showing up on time. You were here before 9:40. I'm proud of you all to hear that. And also we have Haley that was just entering as well. We're going to get started. We have Daniel today that volunteered to be the learning target reader, and he's going to post the screenshots for us. So today, folks, we are going to be working again with fractions. All right, today we're going to deal with fractions again. All right, your reminder, tomorrow is Thursday, so you have a weekly assessment. We'll have a quick lesson tomorrow, and then we'll take an assessment. Today we're going to have the lesson, independent exit ticket, just like yesterday. And then if you finish all that, you'll work on your iReady. You need 150 minutes to get a free 100. All right, everyone pay attention. We have Daniel, and Daniel decided to be our assistant today for notes and reading the learning target. So let me pull up the work for you, bud, all right? So just to let everybody know, I do take daily attendance. Here it is. And we'll go back and I will correct that. All right. All right, so today it is Wednesday, July 7th of 2021, as I said before. We're working with standard 6 NS1. So Daniel's going to read the learning target and the vocab words for us. Good, Daniel. Learning target, sir.
I can add and subtract fractions with the same
Denominators.
and different denominators by using fraction models, and apply to read words same
Situations.
situation.
Great. Okay, let's read the first word, Daniel. Number 1, fraction. Can you read? What does it say? What is a fraction?
Fraction is a number less than 1.
Good. Can you read number 2 where it says numerator?
Numerator is the top number of the fraction.
Good. Can you read denominator for me? Good.
Denominator is the bottom number of a fraction.
Good. And number 4, sir? Simplify or reduce?
Simplify or reduce to make smaller, put in lowest terms by finding the greatest.
Greatest what? Greatest, what's the next line say?
Common factor.
Great. Okay, so this is how we find the LCD, called the least common denominator. We're going to skip count. Okay, so we rewrite the problem, then we're going to skip count, and then we're going to figure it out by rewriting it and solving it. And then sometimes we have to break it down, as Daniel read. We have to make the fraction smaller. Okay, these are really easy. So Daniel, number 1, we have to simplify the fractions that may reduce them. So in question A, we have a circle. We see that there are 4 orange parts and there are 8 altogether. If I had to simplify 4/8, what can I divide both 4 and 8 by, Daniel? What number can I divide by? Any ideas? What do you think?
I think.
What do you think? 2 or 4? What do you want to start with?
4.
You want to, oh, very good. You want to start with 4. Okay. So he says we're going to divide everything by 4. So let's do that. So Daniel, if I divide the top by 4, what's 4 divided by 4, Daniel?
0.
Oh, not 0.
1.
Yeah, there you go. And what is 8 divided by 4?
8 divided by 4 is 2.
Yes. Okay, so that's how you reduce this fraction. Let's look at this one. You want to try the next one, or you want to call in one of your classmates to do letter B where it says 4/16, sir? What would you like to do?
I'll do it.
Okay, so 4/16. What number can I divide both 4 and 16 by? What do you think?
4.
Very good, Daniel. See, Daniel, you're so smart. Check you out. Look at you go. What's 4 divided by 4? We just did it.
1.
Good. And what's 16 divided by 4, my friend?
4.
Good. So 1/4. All right, Daniel. So now we got this. Now we got, I drew a picture for you. We have to do 6/9.
Yeah.
So we have to do 6/9. You want to try that one? I think you can do it. What do you think, Daniel? I think you're capable. Yeah? Okay, let's try it. Good job, Daniel. So we have 6/9, right? So this is 1, 2, 3, 4, 5, 6 of these are shaded. We want to simplify 6/9. What can I divide both 6 and 9 by? What number? Evenly.
3.
Yes, very good. Look at you. You already give me the answers. How awesome is that? Thank you for writing in the chat, guys. 6 divided by 3 is what? Good, Haley.
6 divided by 3 is 2.
Good. And what's 9 divided by 3, sir?
9 divided by 3 is 3.
Good. Daniel, when we finish this page, you'll put it up for us in Google Classroom, okay?
Okay.
Thank you, Daniel. We're going to have someone else do the next one. Thank you for your hard work. Miss Canella created the following equivalent fractions. So I drew pizza pies. We know that there are 8 slices in a pie. If you ate half of a pie, you know that you ate 4/8, which is equivalent to 1/2, or the same as 3/6. Now, right? We multiply 1 times 3, and we multiply 2 times 3. To get from 1 to 4, we have to multiply by 4, as Daniel just did with the inverse operation, right, Daniel? So let's look here. We have 2/3. So this one we're going to have Haley, because I love what you're writing in the chat. I have 2/3, and I want to get to 6 as the denominator. How do I get there? 3 times what is 6, guys? Haley, any ideas? 3 times 3 or 3 times 2?
2.
Good. So whatever I do to the denominator, I do to the
Top.
yes. Okay, let's do it. What's 2 times 2?
1.
4.
4. You thought 1 because you divided, right? So look, I want to show you something. This purple marks is the same as the ones in blue. So 4/6 is equivalent or equal to 2/3. Now, here's the catch. Check this box out. I'm going to put it in red. We're at 2 now, and we want to get to 6. How do we get there? 2 times what is 6? Somebody.
3.
Right. So 2 times 3 is 6. So 3 times 3 is
9.
9. So look, 2, this is 3, this is 4, this is 5, this is 6. Does everyone agree that 2/3 is equivalent or equal to 4/6, right, Daniel? And 4/6 is equivalent to 6/9. So Daniel volunteered to take the screenshot of the first page, and he's going to call it problem 1 and 2 for us. Let me know when you have the picture, bud. Awesome. Daniel, when you post it, call it 1 and 2, okay? All right. Let's move on to problem 3, 4, and 5, or 3, 4, 5, and 6, guys. These are really simple. It says, find the sum or difference for each fraction shown below. Well, if you look here, the first 2 questions have the same denominator, but then the next 2 don't. So I'm going to teach you what to do. Who would like to try number 3 for me? I need help. Marley, where are you, Marley? And I know Jay. Awesome. Marley, what's 1/5 plus 2/5? First of all, what's 1 plus 2?
3.
Okay, so I'm going to shade 1, 2, 3. And we keep the denominator. Good, Marley. Let's do this one. What's 4/6 minus 3/6? What's 4 minus 3?
4 minus
1, and we keep the 6. Awesome. Good job. Let's do this one. Uh-oh, we have a problem here. Are the denominators the same, guys? Or is 2 and 6? No. So what do we have to do? We have to make them be the same by finding the LCD. Remember from the beginning of the lesson, correct? So don't worry about, can you do this without the pictures? We're going to cross that off right now. We're going to actually show the work here. So remember, we have to skip count. So Javon, any ideas? Good. 2, he said 4, 6. Jay, what are the multiples of 6? Can you give me them? 6.
6, 12, 18.
Excellent. Jay, what do they share in common? What number, bud?
6.
Yes, so I have to make, oops, sorry, guys. I have to make the denominators all be equal to 6, as Javon said, because that is what they all have in common. Well, 2 6 is already taken care of, right, Jay? How am I going to get the 2 to be a 6? Well, 2 times what is 6, Javon? Any ideas, bud?
2 times 3.
Yeah. So if I multiply 2 times 3 to get 6, I multiply 1 times 3 to get,
3.
yeah. So check this out. This is what we got. This is 5 here. This is 3, 4, 5. And I love the participation in the chat. So now I technically am going to add what, Javon? What am I going to add now? I'm going to rewrite that here. I'm adding 3 6 plus 2 6 is how many? What is that?
And then
5.
It's what?
5.
Yeah.
5.
5 over 6.
Mm.
Good work, guys. So look, this is 1, 2, 3, 4, 5. This is what the final product will look like with the shaded in pieces. Okay. So Daniel is going to be kind enough again. He's going to screenshot 3, 4, and 5 for us. Daniel, let me just blow it up a little bit larger for you, bud. Okay, Daniel, let me know when you have that. Let me see where you went, Daniel. Let me know when you have that.
Done.
Okay, awesome. So 3, 4, 5, and 6 is done, right? Yeah, okay. So now let's move on to problem 6. It says, can you do these without a picture? So just like Javon did over here, we noticed that the denominators were different. So Jay, you want to help us out again and tell us what to do? Because you did that so awesome.
Yeah.
What do we got to do, bud?
Skip count by 3 and then skip
Yes.
count by 6.
Good. Skip count by 3. So 3, 6.
9, 12.
9. And then he said skip count by 6s. So 6, 12, 18, like he said before. Jay, what do they have in common?
6.
6. Everyone see, it's 6.
See.
Okay. Yes, very good, guys. So we know that we have here, right? Look, we have 3 and 6. So we need to keep the 1/6 the way it is, and we need to get the 1/3 to be equal to 6 and something on the numerator, correct?
Yeah.
So we want to do 1/3 and we want to make it equivalent to 6. So how do we go from 3 to 6, guys? Let's see. Times 2. Very good. I love the participation in the chat. Times 2. So whatever I do to the numerator, I do to the,
Top.
yep. Good. So now I'm going to add the 1/6 plus the 2/6, which is equivalent to the 1/3, right? So now we got 2/6 plus 1/3 is how much, folks? This is really simple. You could do this, all of
3
you.
over 6.
Thank you. 3 over, yeah, 3 over 6. So Daniel, when we finish this page, you can take another photo, okay, bud? All right. Real simple. These are really easy. 2/9 plus 4/9. Anybody come off and tell me?
6/9.
Okay, very simple. We're going to write 6 over 9. Next, 1/8 plus 2/8 is how many?
3 over 8.
Good. This is really easy, and you would shade it if needed. Next, oh wait, I should make that more look like an 8. That doesn't look like an 8. Let me fix that. Okay. Let me make this look like an 8. Okay, next one. 2/10 plus not 7/10, guys. Somebody.
9 over 10.
9 over 10. This is really simple. 3/10 plus 4/10.
7. Top of 10.
Good. 7/8 minus 2/8, folks.
5/8.
Good. Who's saying that? Is that Haley? Nahidalin?
That's me.
Okay, awesome. Nahidalin, 4/8 minus 1/8. Somebody.
3/8.
Good. 3 over 8. All right, Daniel. You are going to be kind enough, sir. That was easy, right? All right, Daniel, there you, it's really easy. All right. Daniel, please do that. All right, so Daniel, let me know once you have this picture. Let's see where you're at. Awesome. We're almost there. 7 and 8. 7/7 minus 4/7 is how much, folks?
Wait, isn't 7/7 a whole because it's the same number?
Right, it is the same
No.
number, which is,
4,
you're right, Haley.
7 minus
Is
4
it
is
a 1,
3.
4?
So this
What was
technically
it?
would be the same as 1, but because we're dealing with the same denominator, Haley, we're just gonna keep it as is.
Oh,
You're right. So 7 minus 3, 7 minus 4 is how much? You're right, Haley.
3,
Good, over. Good. And 5/8,
7.
good. 5/8 minus 2/8, Marley.
3/8.
Oh, okay, somebody beat you to it. All right. Let's do this problem now. And then Daniel will take a photo. Mr. R ate 1/4 of a cake, and I ate 1/2 of a cake. How much cake do we have all together? Well, we got to do a few things here. Remember yesterday we said when we have fractions, we make them a decimal. If you have 1/4, Marley, how much is 1/4, Marley? How much money is a quarter?
35 cents.
Good, Marley, stay right there.
35 cents.
A quarter is 25 cents.
Oh,
Marley, if you have 2 quarters, how much money do you have? 2 quarters. Good. Now I want to figure out the keyword is all together. So what am I going to do? Add or subtract?
Add.
Yes. What are we adding?
We're adding the 25 cents.
So 1/4 plus 1/2, which is the same as 0.25 cents, right?
And
Marley?
then 50.
Good. Good. So what's a quarter? What's 25 plus 50? How much money is that?
75 cents.
And how much is that in money?
20.
Right. So if I have 50 and if I have 50 cents plus 25 cents, how much money do I have? You said 75 cents, which is how many quarters? How many quarters are in 75 cents?
1/3. I mean, 3/4.
Right, 3/4 or 3, right? So we ate together 3/4, which is equal to 75 cents or 0.75 of the cake. Do we all see that? All right, Daniel's going to screenshot this last question for me. Please type yes in the chat if you understand what we just did. I want everyone to type yes if they understood what we did, because today should be a really simple review. Guys, see thumbs up. Let's see who wrote yes in the chat. I got
Done.
Billy, Javon, thank you. Noah, Marley. What about Jason, Jay, Haley, Branson? I need some yeses from you. Okay, Yankel said yes, he understood. Nahidalin said yes. Okay, so this question we did yesterday. Okay, we're gonna look here now. 1/4 plus 3/4. Noah, come off mute and tell us what this is. 1/4 plus 3/4, sir. How much is that? If you're able to, if not, type it in the chat. If you can't come off and say it, type it in the chat, folks. Thank you, Jay. Guys, what's 1/4 times plus 3/4? I need some hints.
It's 3/4.
3,
Good. We got 3/4.
8.
Good. What's 5/6 minus 2/6?
3/6.
Good. And what is, 2/5 plus 3/10? What did Javon tell us to do earlier? What do we got to find?
The least common denominator.
Good. And how do we do that? What did Javon say?
5, 10, 15,
Good.
20, 30,
What do they share?
10.
Good. So they share a 10, right? We all see that. And we know that this is 2/5. So 5 times what is 10?
2.
Okay, so
Two.
5 times 2. So now this becomes a 10 here. So 5 times 2 is 10 and 2 times 2 is,
4.
so now we got, this is the new fraction, right? We're finding equivalent fractions. So 2/5 is the same as 4/10. So 4/10 plus 3/10 is how much?
7/10.
7.
Okay, now this is going to be a little tricky here. It says Dave and Sam take a tour of the chocolate factory in Hershey, Pennsylvania. And I know Marley's in Pennsylvania right now. Right, Marley? It says Dave bought 11/20 pounds of chocolate and Sam purchased 7/10 pounds of chocolate. How many more pounds of chocolate did Sam buy than Dave? So before you do that, it says you got to find the LCD. So how are we going to find the LCD? We got to find the LCD of what numbers? We have 11/20. Right? How many more? We know we're going to subtract, right? Over 7/10. Are the denominators the same or different?
Different.
Different.
So when they're different denominators, what did Javon tell us we have to do before and Haley?
We find the least common denominator.
Good. And how do we do that?
We have to count by tens.
Okay. So let's
And-
do it. 10, 20. And what's 20? 20.
20.
So the equal one is 20.
Okay. So they equal 20. So does everyone see how we got that? Keyword here is how many more pounds. That's why we are subtracting there. Everyone see that? Now, we know that the 7/10 does not have a denominator of 20, but the 11/20 does, right? Now, Heidelin, put the camera on, please. Yeah? Yeah? So we already have the 11/20. We know that that's all set. Correct? Minus. Now, we want to take this and make it be equal to 20, because we found out that the LCD is 20, as you just heard Haley and Yankel do, and some other people in the chat. So how do I go from 10 to 20? How do I go from 10 to 20?
You have to times it by 2.
Good. So 10 times 2 is 20, which means 7 times 2 is
14.
14, yeah.
So now we have 11/20 and we have 14/20. Does everyone see how we got that? We're going to actually rewrite this around the other way. So technically, right, I just wanted to show you something here. It should actually be 14/20 minus 11/20, which is equal to how much?
To 3/20.
Which is what answer?
It's A.
Okay, so we're going to pick choice A as an apple. Now, does everyone see how we got that? Does everyone see how we got that? Ask now if you're like, yeah, I don't know what this woman just did and what these students just did, my peers. All right, so I'm going to put this up so that Daniel can take a nice screenshot for you all. Daniel's going to let me know once he has it all. Daniel's posting this in Google Classroom, correct, Daniel? Okay, awesome. All right, Daniel, you got it, bud? Okay, so this is what we have left. We have an independent practice and we have an exit ticket, and then the remainder of the time you'll be using it for iReady. Are we clear so far? All right, so far so easy, right? This is just a review on fractions because we all could use a review, right? Okay, go ahead, Daniel, go ahead, go to the restroom. All right, so the next agenda states we got to do the independent and the exit ticket. So I'm going to show you guys where that is. It's also on your to-do list, but thanks, Daniel. Well, look at how awesome your notes were, sir. We have the independent practice, which is here. Okay, I would use the notes that Daniel posted. I'm going to open up your responses. Here we go. Okay, questions are pretty simple. We're going to do the independent and the exit ticket, and then when you're done, you work on iReady.